I'm starting. So, welcome to the StatistikA course within the Jade Hochschule Economic Studies and summer term 22. So, what are we doing? We want to do statistics, and if we are doing statistics, then we talk also about the literature. So, this is a general statistics course, as though you can take at least almost every general standard statistics books. And I looked up here some statistics books with a special focus on business and economics. And then you find within these books, especially examples from business and economics. And this is what I think what helps you to learn statistics, because from example, this is in my opinion, the right way to do it. Because only learning the theory and then you have a sample and then you have to calculate some mean, some variance, or you have to test some hypothesis, then you have really to do it. And therefore, we will also do many examples within this lecture. And especially, we will do it with Excel, because Excel is, in my opinion, the program for data analysis, which you have everywhere. The availability of Excel is almost everywhere. You can also download the app of Excel for your for your smartphone and whatever. Or think about that you go to after you graduated here to a little company, to a small company, and then I don't think that you will find their special statistics software. But you will find there, of course, Office, and also our university provides for your students Office 365, so you can just get the license for the Office package from our university. So these are 3 standard books, and then we have a guide to modern econometrics. This is, in my opinion, maybe the best econometrics book which we have actually right now. But in this course, Statistics A, we will not deal that much with the content of this book, because this focuses mainly on time series analysis and so on. But you will find, of course, the linear regression in this book in the first chapters. So just have a look there. But anyhow, if you attend Statistics B, and I'll maybe give this lecture in the next term or in the next summer term, then I will focus, I think, also on this book. Then statistics is the same in every region of the world, and therefore you will find in statistics really many very good open sources resources. And I gave you here 2 resources of open source statistic books. And these are not only statistic books, these are also learning platforms with examples, with many things. Just have a click on the blue written books here, then you will just guide it to the web page. And at last, not at least, I want to recommend also the open courseware of the MIT Massachusetts Institute of Technology in Boston, maybe one of the best universities in the world, because they have a practice of open source. So they just put their lectures open source to be available for everybody. And we just have a so that I can show it to you. And this is actually not only for statistics, but also if it opens here, there it is. You find here topic, and there we have it. So if you scroll down here, oh, I'm wrong. Here I am. Then you find society, social science, and especially here business. So for statistics, the main topic mathematics, then probability and statistics. And then you find here many courses, graduate, undergraduate courses on statistics. Just have a click on this. I think you will find there also very good knowledge about statistics. Okay, so until this point, I think this is enough for the introduction, and we will start then. Oh, this have to be this way. Okay, back to PowerPoint. So we will start the second part of this lecture today with some introduction, some revision, because actually this is the first time I give a statistics lecture here at the Jade Hochschule. I've given already lectures in statistics at other universities in Frankfurt, in Düsseldorf, where I come from. But though I don't know what you have done in your introductory courses in statistics, and therefore we will have today a short introduction, maybe also in the next week, maybe 3 times. We will see, so that I can really get everybody from you, and I'm not coming from some high tower and say, well, this all these things you have already to know, and because then I will lose you maybe in the first weeks, and this is not the way I want to do it. Well, I see here, I think from the names, some guys of you already attended my course in economic policy, and we will also deal with, here is X and Y, we will also deal with linear regression here, but not only with a descriptive way, like we have done it in the economic policy course. We will do here also the so-called inductive statistics. So we will make also hypothesis testing. We will calculate confidence intervals. We will test on significance for, let's say, 99% or something like that. So then we will start with my short introduction or revision, what you know already. And therefore, I start with some keywords, and maybe you can give me a feedback if you already heard of it or if you already know what it is. Best unbiased estimator. What else? What is efficiency? Consistency and sufficiency. Then I already talked about it. Confident interval. One and two-sided tests. Alpha, beta error, or first kind, second kind error. Of course, significance and hypothesis testing. And there we have T, F, chi-square, and maybe, I don't know if we will make it until that, maybe maximum likelihood estimators. So, have you already heard about these words? Because if you know all this, then we have to deal with other content within this lecture. Best unbiased estimator. There we have some how we go to the street, and then we have a sample because we ask the people something, 10 questions or something like that. Yeah, then you maybe have already calculated some mean or so, and then we want to know, is this really a good estimator, what we have calculated? And there you can make some assumptions. When do we call this estimator, this mean, a best as unbiased estimator? And is this estimator efficient? Is it consistent or is it sufficient? This comes all these things come from the last 100 years from decision theory. And really smart guys, they thought about what is a good way to do statistics. And then how good is my sample to really say I questioned 1,000 people, and then I want to to take some clue. Well, I asked 1,000 people, so I say the society in Germany has these preferences. Is this really a good way to do the logic from a sample of 1,000 people? And therefore, we then calculate the so-called confidence intervals. And we can do it from one side or we can do it from two sides. This is one and two-sided test. And then, well, there is really a very important question. We have different types of errors. Mainly in statistics, we only deal with the so-called alpha error. But due to the framework, what do you really want to know with your sample? Somehow you should also ask for the beta error. With a confident interval, there we have also the question for significance. And of course, we will pose some hypothesis and then we will test this hypothesis. And maybe you have already heard about some special probability distributions. So this also a question. Which probability distributions do you already know? Hmm? If I take this density function here, this looks like which kind of probability distribution? Or if we take a density like this, So this would be the normal distribution, and this the uniform distribution. Well, and within the testing, we have many more complex distributions. This is maybe the simplest distributions or the main distributions, so-called. But then in hypothesis testing, we have distributions called T distributions or F distributions, or here chi-square distributions. Though if it is in the student strike too, this is a good question. I hope so, but we have to have a look it up. But I think so. So we can talk about your questions after the lecture, okay? Because therefore we have to look it up. Okay. So then we go on. So am I right that in your introductory courses you don't have dealt with all this I said here? Because this will be then also the content of this lecture. But you know what a probability distribution is, or? But we do it also in the revision. Okay. Because then we start here with some more some simpler content. So we will start with what is a mean, what is a median? Dispersion. The mean, absolute distance, variance, standard deviation, coefficient of variation. Contingency tables and independence. Bayes theorem, random variable, what is it? Of course, probability distribution, density function, and cumulative distribution functions. And I think I will end this revision with the central limit theorem. Have you heard in your introductory course about the central limit theorem? Okay, that's great. Here we will do a revision and then we start with the other content. Okay, great. So then I have already said that I will do it here, my statistics course, doing examples. And therefore, we just start with examples. And here I have some questions for you that we will start. First of all, that we generate a sample, and then we have to look deep into the sample, calculating arithmetic, geometric, harmonic mean, or the median of this distribution. So I don't know, well, you are sitting, all of you are sitting in front of your laptop or something, or computer. So I think many of you have also Excel. So I just open an Excel file. And the first thing we will do is to generate via Excel a sample of the length of 50 male students. They should be at a starting point, yeah, in the mean 157 centimeters, and we should have a dispersion around this of around 25 centimeters. How can we do this? So we start, oops, where's my Excel? There's my Excel. So since my computer or laptop is here, you see it in German. So also the syntax which I will use right now is also in German, but of course, if you just switch to English, then you can do all this also with the English words. So first of all, how many will have 15 male students around 175 centimeters? And we will generate a sample. So we start with 175. Is it large enough that you can see it? Or should I change here to a larger view? Oh, sorry, I can't change. Why not? No, I can change. Looks good? Okay, so maybe you can also open an Excel at your computer or laptop, or afterwards I will give you also this file. So we have 175. And then male students. So 15 should we have. And the syntax here, just to generate numbers 1 to 15. Maybe you know it, 1 plus this one, and you take this down. I think here we are now 15. So now we have 16. And how do we get a sample around 175? We just say this cell equates 175. This we have to fix. And the syntax within Excel is then, if you want to fix this number, that you just, oh, my mouse is here. No, should be here, my mouse, there. That you put a $sign in front of the B and the 1, then you know that always the cell B1 is taken. So, and now we want to generate around this. So we take plus, and then you can take Zufallszahl. Actually, I don't know. So random number. So I don't know how it is called in the English version. Maybe I have to look it up. So, and now if I just put enter and say 1 plus Zufallszahl, then this generates me here 175 plus 0.3373. This just means Zufallszahl generates you a number, a random number within 0 and 1. So we want to have 25 around, then we just subtract from our Zufallszahl 0.5, because this will then mean that we are around 170, plus minus. Zufallszahl generates some number within 0 and 1. If we subtract 0.5, then we are 170 minus 0.5 or plus 0.5. I think this is clear. So hopefully we will also generate somehow another one. Oops. No, okay. I have to go in here. Again, I want to be below. So now we are below 175. So plus minus 25 centimeters. How do I have to manipulate this formula to obtain plus minus in the maximum 25 centimeters? Has John just one of you an idea? Now we get a number within the interval minus 0.5 and plus 0.5. Times 25? Almost. 25 times 0.5 is in the maximum. I think 12.5, or so, but you are thinking in the right way. So do not multiply by 25, but so this here, this is a number plus or minus in the max. Yes, of course, 50. So, and this I really mean is how you can learn to deal with Excel. Just try these simple manipulations by your own. So times 50 means we get a number at maximum 200 at minimum 150. If we really reach the maximum values or the minimum values, just is if we really by random will end up with a Zufallszahl of minus 0.5 of 1 or 0, and then multiplied by 50 will be minus 25 or plus 25. So the nice little thing in Excel is that I do not have always to write always this formula in every cell here, but since I fixed B1 with the $2 signs, then I just can, again, I'm wrong with my mouse. There. I just can copy this formula 15 times. And now we have here really our sample with a length around 175 and maximum 200 and minimum 150. So, and then I make one last manipulation because these very lengthy numbers with after the comma, we can skip this if we take another one, and this is called in German Ganzzahl. This just cuts the number after the comma. And this we do again, copying down Up. No, here we have to go. And then we have a very simple sample of 15 guys. One is a small one, a little one, 150, 45, 54 centimeters. Who is the largest one is here, 194. So if I always click here on enter, then this will generate me always a new sample. And therefore we fix these numbers in order that we are doing here copying and then pasting the numbers. So you see, we already have here generated a new sample. Here you see the formula. Oops, don't see the formula. Here you see the formula is still there. But here, if I click on that, then we have really a sample, and there in this cell you find only the number. Okay, so we generated our sample. I will just save this. And now statistics bar. We go. Oops. Statistic lecture sample 2. So what should we do with our sample? What was the task? Again, calculate the arithmetic mean. What do we have to do? Arithmetic mean. How is it defined? I think this you had in your statistics course, or sum all quantities and divide it by 15. Great. So this would just mean we take 154 plus 198 plus 159 and so on. And here again, you can do it with your calculator. But of course, you can take also your Excel program, and then we can do it in maybe two ways. We can say sum, this is we again in German, so Summe of all these numbers and divided by 15. There we end up 171.8. Or what you also can do is just take the mean, again in German, Mittelwert of the sample, and hopefully this will also generate uns 171.8. Okay, first task. Second one, geometric mean. Where do we always need a geometric mean? Maybe not in this case when we take a sample of a length, but we have a economics course. Where do we always need geometric means? And how is a geometric mean defined? So if we take this, this is 1 over n sum I1 to n xi. This you always need when you're calculating growth rates. Unfortunately, also in many textbooks you find if you calculate the mean of growth rates, then you find there the arithmetic mean, but this is actually wrong. So the geometric mean is just also 1 over n times the product of xi and the nth root. Or you can also write it like the nth root of x1, x2 times xn. So actually it looks quite the same as the arithmetic means. We just interchange the sum sign with the multiplicating sign, and dividing by n is, whoops, this is wrong, just the nth root. And this we do here also. We also do here. So this is the arithmetic mean. Then we take the geometric mean. So, and this we can also do with geo, and then we see in Excel already here that you are provided some options and you find geo middle also from the whole sample, and this is a geometric mean. And there we see it deviates a little bit from the arithmetic mean. So if we want this, we go here. And the last one is the harmonic mean. Do you know what the harmonic mean is? Oops. If you take, for example, you are sitting in your car and you are driving from Wilhelmshaven to Oldenburg. And then it is about 50 kilometers, is this right? What do you mean by no? Have I done something wrong? Or just that you haven't heard from the harmonic mean? So I make an example. So the example is you are driving. Okay, then here comes my example. You are driving with your car from Wilhelmshaven to Oldenburg. And the way to the south, you take 100 kilometers per hour as velocity, and the way back, there's some traffic jam, so you can drive only 50 kilometers per hour. What is the mean velocity? So, and then if you say just 100 plus 50 divided by 2 would be 75, this answer is of course wrong. Why is it wrong? Well, if you take the way from Wilhelmshaven to Oldenburg with 100 kilometers per hour, then you are much faster than the payback. So the time you are driving 100 kilometers per hour is much shorter than the time you are driving 50 kilometers. And then if you think a little bit about it, then you come to the point that the mean velocity, how you can calculate it, is by the harmonic mean. And the harmonic mean, I have some space left. The harmonic mean, so this is a geometric mean, and this was the arithmetic mean, is defined by n over 1 over x1 plus 1 over x2 plus and so on plus 1 over x n. And there also we see, yeah, that also this mean looks quite the same if you write it like this or if you write it like this. It is somehow, yeah, the conversion of the arithmetic mean. If we write it like this, then you see it. So it is n over sum over 1 over xi, I from 1 to n. And this, of course, looks quite the same like this. There are also some other means, but we will stop it at this point. So what do we need at first? Of course, we have here also some formula which we can take, but I will do it, yeah, the longer way. So at first, we just say 1 over this number. Then we have this. Then we have to sum up these numbers. Then we have to invert this number. And at least we have to multiply this number by 15. Now I have done, no, it is also almost in the range of the other two means, 170.3. So this is then the harmonic mean. Well, and if it is really, really important that at first you think about, if you calculate a mean of a sample, what do you want to do? Is the arithmetic mean the right one? Is the geometric mean the right one? Or the harmonic mean, or even some other mean? And this is always the first question you have to pose in statistics, that you really calculate the right number. And therefore also I do it here, yeah, in this maybe longer versions, and I do not take the sample, just put it in SPSS, putting enter, and then everything comes out of the machine. I really want that you see what you are doing. And therefore we will do it in this lecture, the maybe a bit slower version, and not just put the sample within some statistics software, putting enter, and then have the numbers. We will calculate them by our own. Okay, then the next one. What do we have? The median of the distribution. What is the median? Not the number, but how is it defined? Yes, the middle point. This is a good answer. And what do you mean now exactly by the middle point? Can you try to define it exactly? Because somehow this 178, 71.8, the geometric mean, the harmonic mean, these are also somehow middle points of our distribution. But I think you mean the right thing. There are 25 points. If we list them, yes, of course. So we do not have 25, but we have 15, and we list them from the lowest or the shortest person to the largest person. And this we can also do within Excel, of course. Then you go to data, and then you have here sort, and then the largest one at last. And now we see 151, 52, 54, 54, 58, 59, and so on until 198. So, and now we just can say the middle is the seventh largest person. So the median is 165. This is just the answer, and you were totally right. So what else have I asked? Okay, the median, where's my mouse? There. Here's my mouse. These are my two monitors. Sometimes my mouse is here and here. So the median, mean average deviation, variance, standard deviation, and the coefficient of variation. The mean average deviation. What is this? Do you have an idea? This is just defined referring to the other arithmetic mean, that you take this, the arithmetic mean, as the middle of your distribution. Then you take the distance of every point of your distribution. So xi bar minus xi. And then you do not want to divide between guys who are larger than 1.70 m and who are smaller than 170 centimeters. And therefore, we take the absolute value of the deviation and we sum it up over all our 15 sample points, and then of course average deviation, we divide it by 1 over n. This is MAD, mean average deviation. So of course we have also a formula for that, but we will also do it here. Then we have to take abs is the absolute value. What do we need? We need the arithmetic mean. Again, we fix it. Dollar before the C and dollar before the 19 minus the specific length of our person. Then we have every 15 deviations. And again, we sum it up. And divide it by 15. There we are. What else? The variance. What is the variance of a sample? This is maybe the most important dispersion measure in statistics. You have already heard of the variance in your statistics course, or? Yeah, we differ from the mean. This we have already calculated, but I have to know it how it is defined. So it is not the absolute difference and this summed up, but what do we sum up if we calculate the variance? And the reason for this, we will do it later in this lecture. The reason is really deep statistics and really great mathematics, why we calculate the variance not with the absolute distance, but with another measure. Actually, it looks almost the same like the mean absolute average deviation here. Actually, we do not take the absolute value, but with the variance, often abbreviated with sigma squared, means 1 over n times the sum of arithmetic mean x bar a minus xi, but now squared. And this squared, one reason is that we also plus and minus, this does not differ because the square of a negative number is a positive number, but also this square has a deep dependence with the normal distribution. If you recall the normal distribution, then you have f of x is 1 over square root 2 pi sigma x over x minus mu over sigma and this squared. And there you have within the normal distribution also this squared, and therefore we generally calculate the variance with the quadratic deviation. So then we do this also. Variance. For the variance, we need the difference between the arithmetic mean fix minus our number, and now we square it, and this square you get with this hat. Enter. Sum. We have already summed up, so we can just copy this formula here, dividing by n, and this is, if we go to the formula, this is not the variance, this is the squared variance, so we have to take the root, and in German root is Wurzel. So this is MAD, and this is the variance. And the last one is the coefficient of variation. Does anybody know what the coefficient of variation is? Yes, I can do. This was maybe a bit fast. So at first we have to calculate the squared distance between the mean and our number. The mean is here, C19. This we have to fix with the dollar signs, minus 154, and all this squared. Okay? Then we copy this formula 15 times. The next one here is also to sum it up. Up, where are we? There. This is also if you click in Excel in the formula, then you also see which cells, which series are you manipulating. And this is also very nice. So we sum it up. We divide it by 15. And this is a squared number. Therefore, we have to take the root. In German, it is Wurzel. Okay. But you get this file also. I will upload it. Yep. Okay. So the last one. This we also, I think, yeah, 13:45, 3 minutes. Coefficient of variation. Or you are just, everybody is in the internet, just look it up. So how do we look anything up in the internet? This is, oh, the internet is closed. Then I open it. You take coefficient of variation. There we have it. Investopedia. So let's take Wikipedia. Wikipedia is really a good source. It is not an academic source. But if you want to know in a first step what is it, then really Wikipedia is very good. And Wikipedia is, of course, the reason why we have no traditional lexica anymore, because actually it is just better. So standard deviation divided by the mean. Oh, sorry, this is just wrong. I see. The variance is just this. Sorry. The variance are the 261 and the root is then the standard deviation. Sorry. So we have to divide, where it is, the standard deviation by the mean, and then we are done. So 16 over 171.8 coefficient of variation. Then we space this cell. So it is 0. Almost 0.1. So, and therefore we can say, and then we will end this lecture today, we can say that our sample has, a deviation around the mean of 171.8 of about 10%. And the nice little thing in coefficient, not coefficient, is that this measure now is a dimensionless measure. The standard deviation has the unit centimeters, the mean has the unit centimeters, so it cancels out. So here we can really say this almost 0.1 means we have a dispersion around our mean of around 10%. And this is also often very helpful when you want to compare different samples with different units. Is the dispersion of this sample higher or lower than in the other sample? And this you cannot decide if you have different units and the coefficient of variation. This normalize somehow the dispersion number of your sample. Okay, well, this took a bit more time than I thought, but anyhow, I want to pick up you where you are, and yeah, there is it is not good if I take here all these mathematics you should have had already seen, and then starting calculating. Therefore, then we take also next week for the revision. And then I give you some homework, especially this number 4. You should generate another sample of female students with a maximum deviation of 20 centimeters and starting from 165 centimeters. And then maybe if you didn't hear already about a contingency table, just look it up in statistics books or in the internet and try to calculate the marginal distribution if we put then these two samples of males and females together, calculating the marginal distributions, and then we can also from the empirical probabilities, then we can decide, is there a dependence? If are these two samples statistically independent or are these samples statistically dependent? Um, I think with the calculator, do you really have to learn this with the calculator? You take you of course you get all these formulas, and you get also a set for the exam with the formulas. And of course, if you then start to type in, but you can be sure I do not give you for the exam questions where you have to calculate with the calculator 25 numbers or something like that. Because then you just sit there typing in your calculator 15 minutes, and well, this is not what we want to do here. Okay. So there was another question, I think, but then I stop the video. You think about your homework.